Hello everyone, welcome to my channel. Today we'll be learning about Moore machines. So first we'll discuss that why do we need a Moore machine. So what happens in a finite automata is that we either get two output, that is either the input is accepted or it is rejected. To solve this problem that arises due to the output pattern of a finite automata, we use the concept of Moore machine. And this problem that is faced in a finite automata can be approached in two ways. First is when the output associated with the current state. And the second is when output is associated with the transition state. The first one is known as the Moore machine type, and the second one is known as the Mealy machine type. In this video we'll be discussing about the Moore machine type and how do we define it. So Moore machine is defined by 6 tuples, namely S, sigma, delta, del, lambda and S naught, where S is the finite non-empty set of states, epsilon is the set of input alphabets, the capital delta is the set of output alphabets, the del, as we know, is the transition function, the lambda here is the output function, which in case of Moore ranges from S to delta, that is the set of states to the output alphabet. First we'll take an example of Moore machine. Now we'll draw the state diagram, taking the states to be Q0, Q1, Q2 and say Q3, where the start state is Q0. In case of Moore, every input state has an output value associated with it. So we'll take this as Z is equal to 1 associated with Q0, Z is equal to 0 associated with Q1. Similarly for Q0, Z is equal to 0 and Z is equal to 1. So assuming that when the input is 0, Q0 goes to Q0 and Q0 when the input is 1 goes to 1. Similarly we'll draw the rest of the diagram. Goes to Q2 when there is 1, say it goes to Q0 when it is 0, Q3 goes to Q0 when the input is 0, Q2 goes to Q3 when the input is 1, Q3 goes to Q3 again when the input is 1, and Q2 returns to the state Q2 itself when the input is 0. So now for this state diagram we'll be drawing, or rather making, a transition table. So to do that, to make a transition table, we'll make 3 columns say present state, the next state, and the output symbol, which is in this case is Z. So in next state our input can be either 0 or the input can be 1. So the next state will be decided on basis of what is our input, whether it is 0 or 1. So we make two subdivisions in this. So first we'll write all the states that we have in the state diagram of the Mealy machine. So here we have Q0, Q1, Q2 and Q3, where Q0 was our starting state. As now we can see from the state diagram, when Q0 has the input 0, it returns to Q0. When Q0 has the input 1, it goes to Q1. When Q1 has the input as 0, it goes to Q0. And when Q1 has the input 1, it goes to Q2. Similarly, when Q2 has the input as 0, it returns to Q2 itself. And when it has the input as 1, it goes to Q3. When Q3 has the value as 0 or the input as 0, it goes to Q0. And when it has input as 1, it returns to Q3. And for the output symbol, as we can see, Q0 has output symbol Z is equal to 1 associated with it. Similarly for Q1 we have Z is equal to 0. For Q2 we have Z is equal to 0 again, and for Q3 we have Z is equal to 1. So hence this is our transition table for the state diagram that we made here. So this is how we make a transition table from the state diagram in case of Mealy machine. Thank you.